How do you find the antiderivative 1 over 3 plus 5 sine x? First thing is to use the substitution x is equal to twice the arctangent of u. Okay, and how would you find that? You find that by first realizing that u is equal to tangent of x over 2. Okay, so that would be your first substitution, and then you would use the arctangent to solve for x. Take the arctangent on both sides, you get arctan of u is equal to x over 2, and then x can be isolated by multiplying both sides by 2. You get this substitution. Okay, so now we can find the dx, the derivative of both sides, so that we're going to need it for this substitution, right, for this numerator, and then we're going to find sine x. So the dx is going to be what? It's going to be 2 over 1 plus u squared du. Now sine x, we're going to use the x again. So sine x is going to be taking sine on both sides, right? So sine of 2 arctan u is, using the double angle formula, 2 sine of the arctan times cosine of the arctan. Right, so how do you find these values? Arctan u means the angle, so suppose this is the angle whose tangent is u, right? So tangent of this angle, let's name it theta, is u divided by 1, opposite over adjacent. Thus this side, the hypotenuse using the Pythagorean, is going to be u squared plus 1 inside the square root. Alright? So now we can find the sine and the cosine, right? Because we just found all sides, right? So sine x is going to be twice. The sine is going to be opposite over hypotenuse. Right? So u over square root of u squared plus 1 times the cosine, adjacent over hypotenuse, 1 over square root u squared plus 1. So this is equal to 2u divided by, the square roots are gone, 1 plus u squared. Perfect. So now the substitution, let's separate this work. We're not going to need it. This is only for substitutions. Now we're going to get what? dx is this, 2 over 1 plus u squared. Let's leave the du until the end. And this is 1 over 3 plus 5 times sine x. Sine x is this, 2u over 1 plus u squared du. Right, so now what are we going to have? We're going to have, let's put 2 outside, 1 over 1 plus u squared times 1 over, and this simplified is going to be what? 3 plus 3u squared plus 10u, right? So let's use it as 3u squared plus 10u plus 3 du. So now how do you factor this denominator? But we're not done yet, right? Because 1 plus u squared will be the denominator of this denominator, right? So let's put it on the top, because it will be on the top eventually, right? 1 plus u squared. So guess what happens? These two guys will cancel out, so we're left with a simpler integral, 1 over 3u squared plus 10u plus 3 du. So now it remains to factor this. How do you factor this? I'm going to do the factoring here. So notice that 3u squared plus 10u plus 3 can be split as 3u squared plus 9u plus u plus 3. Right, I'm splitting the 10u basically into the sum of 9u and u. Now what I see is, I see u plus 3 being participant in these two, right? Because I see a 3 and a 9, and I see the u squared and a u. So I know that u plus 3 is definitely a factor here. Basically what you're going to do is, you're going to say, you're going to take the 3u out here, because that's the greatest common factor of these two, and then you're going to have u plus 3 as a result, and then plus u plus 3 as before, right? So now look what happens. the 3u multiplies the u plus 3, and the 1 multiplies the u plus 3, right? So we can take the 3u, the sum of 3u and 1 outside 3u plus 1, since both of them will multiply u plus 3, and both of them are added, right? Essentially, because there are always plus signs. So this technique is called factoring by grouping. Okay, so we found the factors by using the grouping method. So basically now this integral becomes 2 integral 1 over 3u plus 1 being multiplied to u plus 3 du. So now you're going to use partial fraction decomposition, obviously, right? And partial fraction decomposition, we're going to do the work here. Hopefully we have enough room. So multiplying, let's suppose that this is the fraction that we started with, right? If you multiply both sides by this, first let me write it as 1 over 3u squared plus 10u plus 3 is, bad fraction, is equal to this, right? So a over 3u plus 1 plus b over u plus 3. Right? Multiplying both sides by the denominator, you will get 1 is equal to a times u plus 3 plus b is equal to 3u plus 1. Perfect. So now look what happens. We're going to compare coefficients. The first one, comparing the constants. 1 is equal to 3a plus b. The second one, comparing the u now to the first power, there's nothing in the u, so 0 is equal to a plus 3b. a plus 3b. So now, basically if we multiply both sides by 3 and then subtract, well, how about by negative 3 and then add? That would be easier. Right, so multiply both sides of this equation by negative 3 and then add. Right, then you will have eliminated the a, so you will get negative times 0 is still negative, right? So 1 is equal to, the a is eliminated, and then b minus 9b. b minus 9b is negative 8b. Perfect. So b is equal to negative 1/8. And a is, well, we need some algebra for a, don't we? A is negative 3b, right? So minus 3 times negative 1/8, negative 1/8, right? So 3/8 is the b. Perfect. So now what do we get? We get 3/8 is the a, right? So let's use this for the first integral. 3/8, 2 times 3/8, right? So 2 times 3/8 integral 1 over 3u plus 1 du plus b. b is negative, right? So minus 2 times 2 over 8, right? 2 times 1 over 8 is 2 over 8, right? Integral 1 over u plus 3. u plus 3 du. And again, you can already see ln here because there will be no numbers involved. If you set this to v, dv is going to be just, well, actually there will be numbers, I'm sorry. dv is going to be 3 du, right? So you will need 1/3. So we can actually, well, I'm going to write too many numbers, but there will be 1/3 involved, so we can actually disregard this 3 because there will be 1/3, and 2/8 becomes a 4, right? So 1/4 ln absolute value 3u plus 1. For this one, luckily we will not have any numbers popping up other than what we already have. So if we set z is equal to u plus 3, dz is 1, right? So nothing changes, but this becomes negative 1/4, right? So minus 1/4 ln absolute value u plus 3 plus a constant. So let's put everything in terms of one answer. 1/4 is a common one, right? So 1/4, and let's put everything under one fraction, because subtracting one ln from the other means the inputs, this input will be the denominator, this will be the numerator, right? So basically 3u plus 1. But let's put everything back in terms of x. U is tangent of x over 2, right? So 3 tangent of x over 2 plus 1 over tangent of x over 2 plus 3. Oh, I'm sorry, I forgot the ln. Oops. This was 1/4 ln. That would be a crucial mistake if you left it like that. 1/4 ln, right? So tan of x over 2 plus 3. Plus 3, absolute bar closed, plus a constant, right? So this is your final antiderivative. If you did it this way, if you got this answer, it means you did correct work. Thank you so much for watching. I hope this was a lot of fun, and see you in the next video.